Experience tranquility as you drive through the population-free, lush green slopes of Waknaghat, Solan. To reach functionality and aesthetically spread 25 acres of easy-flowing and community-friendly landscape. Welcome to Jaypee University of Information Technology, Waknaghat, Solan. Set up in 2002 under the Extraordinary Gazette Notification of Government of Himachal Pradesh. This is the only private university in the state whose chancellor is the governor of Himachal Pradesh. With one Experience tranquility as you drive through the population-free, lush green slopes of Waknaghat, Solan. To reach functionality and aesthetically spread 25 acres of easy-flowing and community-friendly landscape. Welcome to Jaypee University of Information Technology, Waknaghat, Solan. Set up in 2002 under the Extraordinary Gazette Notification of Government of Himachal Pradesh. This is the only private university in the state whose chancellor is the governor of Himachal Pradesh. With 108 professors, most of whom are PhD from reputed universities around the world, JUIT offers BTech, MTech, MSc, PhD in computer science, IT electronics and communication engineering, bioinformatics, biotechnology, and civil engineering, whose curriculum is supplemented by SWAYAM and PTEL. A home to almost 2,000 students, this university is twice accredited by NAAC. The world-class state-of-the-art infrastructure of JUIT has 57 labs, including Virtual Lab, eYentra Lab, IoT, lecture theaters, classrooms, tutorial rooms, laboratories, vast auditorium, administrative and faculty offices, an enormous library, and 6 well-equipped gyms. The campus is designed with a vision of creating a university of international repute and highest global standards. Fully equipped with learning tools and web-based educational environment, the campus is planned for the advanced computing infrastructure. Facilities like bank, temple, and helipad are all within the campus. JUIT takes pride in being a member to IEEE Chapter and Computer Society of India Chapter. It also conducts student exchange programs with the University of Nebraska, Omaha, and University of Florida, USA. To give an experience of the real corporate world and understand the challenges that lies ahead, our students also get an opportunity to connect with industry professionals and self-made entrepreneur. Our exclusive placement cell has an excellent placement record. All this has brought us several accolades. We're ranked among the top 100 engineering institutes by NIRF, MHRD. We've been declared Best Private University of Himachal Pradesh by Dialogue India in 2018 for academics and infrastructure. We're also ranked first under category of value for money and third under the category of top private university in 2018 for offering value for money education by India Today. With a hygienic mess named Annapurna, well-furnished hostels with single and double rooms, mechanized laundry, 24/7 water supply, complete power backup, and Wi-Fi connectivity. We ensure that students feel at home while they're away from home. The overall growth in personality and confidence is taken care by conduct of debates, declamation contests, and a host of indoor and outdoor games. NCC Wing for Girls and a vibrant youth club that organizes popular sports festival called Pathak, literally festival and cultural festival, which further heightens their energy levels. They're also encouraged to develop independence in thought and action, as well as trained to deploy appropriate technology paradigms for given tasks, explore new horizons, and lead teams to solve complex problems. With our learner-centric educational process, students are free to find their own paths and learn their way to limitless opportunities that awaits them. So be a part of Jaypee University of Information Technology, Waknaghat, Himachal Pradesh, to be the leaders in innovation, entrepreneurship, creativity, and management. Because this is where we engineer lifelong learners.
A very warm welcome to one and all on behalf of JUIT Chapter of Indian Green Building Council. I'll first of all like to welcome our guests for today, our speakers, Colonel Shailesh Pathak ji, Mr. Amith ji, Architect Shelja Gupta ji, HOD of Civil Engineering Department, JUIT, my colleagues, friends, and so many participants who have joined us through Google Meet and YouTube Live for this session. So we welcome you on the virtual session on various aspects of green building design, which is organized by IGBC Student Chapter of Jaypee University of Information Technology, Waknaghat. Let me also congratulate each and every one of Himachali for Himachal Pradesh Statehood Day today, which we are celebrating. On 25th of January 1971, Himachal Pradesh was constituted as a state, and today we are celebrating that day. On this momentous occasion, this whole week, Indian Green Building Council is also celebrating Harit Prem Bharat Mahotsav from January 23 to 29, and this small session today is a part of the same, where we will have a talk upon various aspects of green building design. Basically, Harit Prem Bharat Mahotsav is the largest green event in the country, organized by Prem Jain Memorial Trust and curated to promote sustainability and create awareness about a greener way of life amongst the future generation. The Prem Jain Memorial Trust promotes Dr. Jain, who is a green champion, the love for sustainability and Mother Nature through week-long celebrations each year from 23rd to 29th January every year to commemorate Dr. Jain's birthday anniversary on 26th January. The Mahotsav is carefully designed calendar of activities and events links to sustainability held across the length and breadth of the country. So this initiative today taken by JUIT chapter of IGBC is under Harit Prem Bharat Mahotsav. So without further ado, I like to invite our first speaker, Mr. Amith MC, who is an Associate Counsellor of Green Buildings at CII-IGBC Hyderabad. I will like to just introduce him once. He is a sustainability and green building consultant with more than 8 years of experience in green building certification, sustainability standard development, ESG facilitation, policy consulting, audit, resource efficiency, strategy, and climate change mitigation. Amith is leading IGBC's green logistic parks and warehouses, green new building, and green campus rating systems. He has facilitated more than 350 green building projects across different typologies to achieve desired rating level. He has also trained professionals and students on green building concepts and has thus far conducted training programs for more than 5,000 plus green building professionals and students in the country. Amith is instrumental in developing the IGBC's rating system on net zero carbon framework, logistic and warehousing, commercial, campus, and residential sectors. Amith holds a master's degree in energy system from SJCE Mysore and a bachelor's degrees in mechanical engineering from VTU Karnataka. He is IGBC accredited professional, IGBC trained faculty and assessor. So without further ado, I will like Mr. Amith to please take over the stage. And again, we welcome all of the dignitaries, including Colonel Shailesh Pathak, Mr. Amith, Architect Shelja ji, our HOD Ashish Kumar, Department of Civil Engineering, and we like his blessings to start this program. If you say, sir, Ashish sir.
So, good morning to all of you, and on behalf of Department of Civil Engineering, I warmly welcome all of you in this session on the green building designs, and I also appreciate all my external speakers of the session, Mr. Amith ji, Shailesh ji, and Shelja ji, that they have given time and given us opportunity to interact with all of you, and also apprise the latest trends in this area on various aspects of green building designs. So I think that, and it is my firmly belief that that session will be beneficial to all of us and all the community who is working in that area. And I will take not more time. For this, I wish best of luck to all the participants, so that, and I firmly believe that they will get all knowledge in that area. Over to you, Tanmay.
Thank you so much, sir. With these kind words of sir, as we are very limited in time, I like Mr. Amith to start with his presentation. Over to you.
Yeah. Thank you, Ajay sir. Thank you, Tanji, for the introduction. I will just share my screen.
Yes, sure.
I hope my screen is visible. Yeah. So once again, very good morning, participants and audience to green buildings. And at the outset, I would like to thank the JUIT for organizing this session, and also thank the Prem Jain Memorial for organizing the Harit Prem Bharat Mahotsav. And again, thank you for the opportunity provided so that we could interact with your students today. And in this session, even though we are a bit limited on time, we have to cover a few things. So we will first basically being a IGBC Student Chapter, we'll discuss a little bit about what IGBC is and what it does. We'll look at what a green building exactly is, how is it different from a conventional building. We'll look at what are the features that is required, or what are the parameters that one should look at while looking at a green building. I will also look at what are the benefits that green buildings have to offer. And 2021 was a landmark year from a sustainability point of view, because India as a country declared that we'll be net zero in emissions by 2070. So net zero is going to be the next the most important thing from a sustainability point of view that we'll be doing. So with respect to how do we create the pathway towards that net zero, that is the thing that we would like to also discuss in this presentation. So to start off with, as all you're aware, IGBC Indian Green Building Council was formed by CII, Confederation of Indian Industry, and CII is an apex industry association known for its policy advocacy in India. So CII formed IGBC in 2001, and we initially we had a different vision. We thought if we could give at least 1 square feet of green footprint for every individual in this country, we would do a decent job. That roughly equated to around 1 billion square feet which we surpassed a long time ago. So we then revised our vision. We thought it's we should have a larger vision, and that's when we thought we should facilitate India to be one of the leaders in sustainable built environment, and we should enable a sustainable built environment for all the Indians. And the unique thing about IGBC is that IGBC was the first green building certification body in India. And also it is the most widely used green building certification tool in India. So more than 90% of all the green buildings that are certified in India are actually certified by IGBC. The other unique thing about IGBC is that the recognition that you get on a global platform. IGBC is part of WGBC, which is World Green Building Council, which is a network of over 70 countries. So once your project gets recognition, or once your project gets certified here in India, so that is, and IGBC is the only council from India to be representing India on a global platform. So this is actually a very landmark building in the Indian construction sector. This is this CII Godrej Green Business Center. This is the first green building in India, and also the first platinum rated green building in India. And the uniqueness about this is that there were other counts in before 2001. Other green building councils were there, but they were operating out of a non-green building. They were preaching about green building, but they had not practiced it. So that was the thing we wanted to change. We wanted to first practice the things before we start teaching it to others. And with that objective, we formed a center of excellence called Sorabji Godrej Green Business Center, wherein we wanted to showcase to the country that it is possible for us to integrate our traditional Indian architecture with modern day technology to give you a classical looking building, but at the same time, the building will be state of the art. So just to give you, an example, so you can see certain traditional Indian architectural elements, something like a jali wall, the traditional courtyards that you can see, wind towers or wind scoops, and tree hugging structure. So these are all very traditional Indian architectural elements used in our buildings. At the same time, this is blended with a very efficient air conditioning system, with efficient lighting system, controls. It has a building management system, renewable energy on it. So it's an example or it's a model green building that even today many of the stakeholders, thousands of stakeholders visit this building to understand the green features and then try to replicate that in their projects. Before we discuss what green building is and the benefits, we can probably take a step back and look at from a macro perspective and understand why is it that we require sustainable development, or why is it that we require green buildings in India. So from an Indian macroeconomic perspective, when you look at India is a rapidly developing economy and very fast growing economy. That means there's a lot of demand that comes in, especially from infrastructure projects. So it could be your buildings, or it could be other infra related projects. So we have huge amount of urban that is happening, very rapid urbanization that is happening, and we'll be adding more than 40 crores to our urban population in another 3 decades. There is major infrastructure projects going on, new ports coming up, 8 new metro projects going on. There is a very ambitious housing for all project that is happening, and there is a ready to occupy. And this is not the demand that comes from design. This is ready to occupy of around 125 million square feet in per year, and this is only for the top 6 metro cities of the country. So all in all, if you look at how much of building there is and what kind of demand can come up in the future. So right now we have, if all the buildings put together, we have somewhere around 35 billion square feet of building. And this is times to 110 billion square feet by 2050. Not even 1/3 of India is yet to be there for the country. And on the other hand, if you look what there is a net of coal, reserves of coal, iron ore, is also, and with the current rate, all of these resources will be depleted in the next 2 decades or so. We are a very water-stressed country with 40% of the population without access to actually, proper drinking water. We have lost more than 20% of our green cover in the last 100 years. And as a result of all of this, we also have the tag of having the most polluted cities. So 6 out of the 10 top polluted cities are actually from India. So what this shows is that there is an imbalance between what we need to achieve and what we are actually using. There is an imbalance between how much we have to conserve and how much we are consuming, right? And if we don't balance this out right now, there is going to be a huge amount of issue that will happen in 2 or 3 decades because of the kind of demand that we have. So sustainable development will ensure that we have consume and how much we. So what exactly do we mean by a green building? So a green building is one which conserves natural resources. It's a one which uses less water. It optimizes energy efficiency, generates less waste, and very importantly, it provides you with a healthier living spaces. And so just because it's a green building doesn't mean it's out of this world or it looks something different. Both from an appearance wise or from building usage point of view, the difference is nothing, it remains the same. But the difference that you get is actually from the operational savings that you get right from the day. The difference is the quantum of natural resources that you can save by opting for a green building. And the difference comes in the kind of health and well-being that you can provide to the end users, the enhancement in the productivity levels that you can provide to the end users. So these are the differences between a green building and a conventional building. Now, green buildings, if you look at it, it's actually not new to India. I mean, if you look at, we have a very rich heritage, very rich architecture. So if anywhere across India, you will find a lot of buildings, a lot of monuments that have actually stood the test of time, standing for centuries together. And even today, some of these buildings perform way better than a conventional building. So that is the kind of rich heritage we have. And all of these buildings, though they might not be certified officially as green buildings, but they are actually green buildings because they address what we call the Panchabhutas or the elements of nature. So you go to any of these buildings and you will find that there is always the element of nature of water. So there will be a tanka or there will be a talab, a water body that to collect rainwater. There will be a courtyard for circulation spaces. The building will be usually constructed with the local materials. There will be efficient use of daylighting. So you will be getting daylighting only in the spaces that you want daylighting. There is very good usage of architecture elements for your views. So in a way, all of our ancient buildings were addressing this elements of nature, and that was the reason why they were actually green. So in IGBC, what we're trying to do is that we are trying to rediscover our Indian ethos rather than copying what the West has to offer us without any benefit. So green building point of view, we look at the 5 key elements. We look at how good the site on which the building is built, how good the site is planned, and how good the site is utilized. We look at what are the water efficient strategies being used. We look at what are the energy efficient strategies used. We look at what kind of building materials is being used for construction, how well the waste, both the construction waste as well as the municipal waste that is getting generated, how is it utilized in the project. And we look at what kind of indoor environment quality or how good the indoor environment quality that the project has to offer you. So these are the 5 elements on which we look at a green building. And each of these areas, when you try to look at, or when you try to convert a conventional building into a green building, there will be some challenges, at the same time some opportunities in each of these areas. So give you just to give a little bit of further details on this. So when we say site selection, the kind of challenges that is there presently, first and foremost, there is issues with the compliance. Many of the projects do not have proper regulatory clearance, and clearances will not be there. The topsoil will be an end-to-end excavation. They'll throw out those topsoil, and when they are about to complete the project, they realize that there's no soil remaining. So you borrow soil from some other side. You're disturbing the trees that were there in the existing sites are all cut down. They are not. No one is bothered to either transplant the trees or retain the existing trees. No one gives a thought about it. And because of that, there is a gradual loss in green cover. And because of this loss in green cover, there is an urban phenomena called as heat island effect that gets generated. So heat island effect is nothing but a rise in the local temperature by 2 to 3 degrees compared to an area which does not have higher density of construction. So, for example, if you go to a downtown of any city, you could go to Gurgaon or Chandigarh, the city center, you will feel it's almost 1 to 2 degrees. You actually feel that heat. Whereas in the same city, if you go to a park, you will feel it's a bit cooler. So this is called as heat island effect, and it's more predominant in buildings which use a lot of glass, steel, cement, all kind of lighting fixtures, project that come out during the night. So there's also no access given to differently able. If a differently able person is to enter a conventional building, construction workforce, these are some of the social issues that we find is not catered in the conventional point of view. So we have made it a point to address all of these in the rating system. So the mandatory requirement, we have building regulations. Topsoil preservation is another mandatory requirement where you need to stockpile the topsoil within the site and reuse it. We are encourage the project to blend in with. I mean, we understand there will be a little bit of disturbance, but just to give you an example, if you can see middle row photographs here, this is our own office. You can see that we have not just blended in with nature, we have actually enhanced the nature. We have put in trees. So in fact, this is one of the only pockets of high-tech city which is very lush green. So this is in Hyderabad. So in order to mitigate heat island effect, you can go in for a SRI tile, or you can go in for more shading from trees, or you can go in for roof vegetation. So these are some of the concepts that is being addressed in the rating system. Similarly, you look at water. Water is a huge topic in India, very debatable, and we are a very water-stressed country in the world. There is no doubt. Even the fact that we have the 9th largest water reserve in the world. So even though we have the 9th largest reserve, we are still very water critical because we have 17% of world's population. So managing this 3% of world's water to 17% of world's population is where we are all really struggling. And to top it up, we have actually abused our groundwater to the max level. So groundwater is a very good source of water, but in most of the cities, because of the rapid usage of groundwater, the groundwater level is now depleted, and it may be running out in more than 21 cities. And because of this rapid urbanization, there is a lot of stress on the municipalities, and many of the times there will not be any proper sewage connection lines, there will not be any drinking water facilities because of this rapid urbanization. So these are real on-ground challenges that happens. So to address this in the rating system, we have gone for the very simple the very reliable and effective 3R approach, wherein we are recharging each and every drop of rainwater that is falling on your site. We are trying to reduce the potable water demand only by using efficient water fixtures, and we are trying to recycle all the treated wastewater for our non-potable application, such that we cut the heat gain coming in. So first thing you can look at is the orientation of the building. Orient your building such that the south and west, which bring in a lot of heat, have minimal openings on those orientations so that the heat can be cut in. Building envelope again is very critical, especially the glass. So glass is a very important component of a building. It is very useful for bringing in daylight, but at the same time, because glass is transparent, all the three types of heat transfer happens in glass. That is conduction, convection, radiation. All the three types of heat transfer is happening in a glass. So how much glass to use, where you should use the glass, and what kind of glass you should use is very important. Now, even though you have maximized your orientation, your building envelope, there will be still some heat developing. So there will be internal heat, like because of human beings, there will be internal heat load coming in. Because of machines, heat load might be coming up. So you will still require to efficiently pump this heat from the building and throw it outside. So you require very good air conditioning system. You can use passive architectural elements to pre-cool this. Then whatever you're consuming, you can offset it by going in for renewable energy, either on-site or off-site. You can use building management system to sort of automate things, to minimize human error. And the building management system can also predict. It can predict what would be the temperature after 5-6 days. So how much chiller load should be there. So there is a lot of prediction that can happen with artificial intelligence, machine learning, and so on. So all of this, if you can do it with something called as a simulation. So that is, you need not do it on ground actually, but all of this can be done through an energy simulation. You can come to an ideal orientation. You can bring out your ideal material that should be there for your building envelope and so on. So this is what can be done from an energy efficiency point of view. Next is on building material. So waste is a very important component. How do we manage the waste is very important. Waste segregation in India is actually next to negligible. And most of the waste, which is not, we are not able to segregate, is going into the landfill. The other is on construction and demolition waste. So as much as 40 to 60 kgs of C&D waste gets generated for every square meter of building that you build. So that is a huge C&D waste. And if you don't segregate and reuse it within the site, all of this is again going into your landfill. So India has one of the most number of landfills, and most of the landfills in India are overflowing. That is the kind of waste that we generate every day. And the other thing is the material that you are using, are they sustainable in nature or not? So these are the challenges that are there. So in the rating system, what we encourage the project is to first segregate the waste. So the municipal waste, segregate it at source. Once you segregate it at source, you will find, either it can be upcycled or it can be downcycled. The wet waste or the organic waste can be treated into manure and reused for your landscaping. Your construction and demolition waste also, if you segregate, probably the image that you can see on the bottom, brick pad coba, once you segregate your brick waste or your cement waste, it can be reused within the site somewhere. And the others can be sent for recycling. Then when you're selecting a material, always be mindful that try to select materials which have high recycled content. So something like a fly ash is a waste from thermal power plant. So if you use bricks that is made up of fly ash brick, if you use bricks made up of fly ash, you are actually using a material with high recycled content. So try to use materials which are of high recycled content, materials which are locally manufactured. And there is another product certification that we have, which is called as Green Pro, which is Green Product Certification. It's an eco-label. An eco-label is something wherein the complete life cycle of the product is taken care. That is, how efficiently are you drawing the material from its ore, how efficiently is it manufactured, how efficient is the supply chain, whether you can reduce CO2 emissions from the supply chain, and then how easy is it for the material to be reused into the next cycle. So a complete life cycle assessment is done. So you can probably check this website. It's called CI Green Pro. This is the only eco-label from India. So these are things that you can do from the building material point of view. And lastly, when you look at the indoor environment quality, because this is very important, especially from this pandemic point of view also, because 90% of our time we spend it indoors. And in such scenarios, if you don't have proper daylight, if you don't have proper ventilation, or if you don't have proper access to views, you tend to develop certain illness. There is an unexplainable itchiness on your throat, or your eyes get watery. So this is called a sick building syndrome. It's predominantly there. It's not widely recognized, or it's not widely accepted, but that is a phenomena that happens, and that is the reason why you should ensure that your building has proper air quality. That is, you should have proper amount of fresh air coming in, because we are all breathing CO2. That CO2 has to be thrown out of the building. So you need outdoor air to come in and to purge this CO2 out. At the same time, the kind of material that you're using, the paint always gives out VOC, that is volatile organic compound. So your furniture, your paint, your carpet, all of that will be giving out certain VOC. So you should have adequate airflow coming into the building to exhaust all of these. And at the same time, daylight and outdoor views are also very important. So if you don't get daylight and outdoor, it affects with your cognitive skills. Your cognitive skills will start going down once you always are in a closed environment, and you don't get proper light hitting your skin, or you don't have proper views to the exterior. So this is how the indoor quality of a building is also looked into. So I think recognizes all of this. It recognizes the local climatic conditions, and it gives guidelines to the project proponents according to that. In IGBC, all the baselines that you see, that is National Building Code of India or ECBC, MOEF, all of these are the baselines. By default, the project will meet and perform way better than these baseline. So what are the benefits that you can expect? You can expect somewhere around 30 to 50% in energy savings over ASHRAE code or over ECBC code. So if you design your building according to ECBC, then you will not get any savings. But if you design it according to green building principles, since ECBC is a base case, you will be performing way beyond than the ECBC requirement. So these are some of the benefits of the first three green buildings. This is way back in 2003, 2004. So almost 15, 16 years ago, this is the kind of energy savings that you could get. So imagine a company like Wipro getting 1 crore of energy savings from one of its buildings. That is a huge amount of tangible benefits that one can experience. Similarly, there are certain intangible benefits that cannot be measured. I mean, I cannot quantify how much reduction in the impact I caused on the environment, or I cannot really measure the productivity, but these are something that can be experienced by the end users. So these are the intangible benefits that you get from a green building. So the normal question that comes to everyone's mind is, do green buildings cost more? And the answer is, it depends on the various parameters. If you look at only first cost, yes, green buildings might be costlier. But if you look at the life cycle cost, green buildings work out to be way cheaper than a conventional building. So these are the examples of how incremental costs have come down over a period of time. That is because the materials, green materials and technologies are now more affordable and really as compared to what it was in 2001. So as of today, so this is 2021 Indo-Space Logistic Park. So it's a very large logistic park, and it had an incremental cost of only 1.7%, which was, they got the payback within 3 years. So if you compare this with a conventional logistic park, they get their money's worth is 3 years. From 3 years onwards, green building becomes an incentive or a profit for them. So just to give you an example, this is how the cost of the green products have come down over a period of time. So another example is solar PV. So back in 2003, solar PV used to cost somewhere around 3 lakh rupees for 1 kilowatt, whereas today you get 1 kilowatt for 50,000 rupees. So there is a huge reduction in the availability and also the affordability of the materials. So these are some of the impacts that all the certified projects of IGBC has. So there's a 15 billion unit of electricity saving every year. 46 billion liters of water gets saved every year from our projects. And very importantly, 12 million tons of CO2 reduction happens because of the projects that is getting certified. There are also certain incentives that are given by various state authorities on IGBC certified projects. So you get something on extra FAR, which is you can build extra without paying for the tax for it. There is property tax rebate going on. There is another financial aid that will be given by various governments. So various types of incentives are available for certified projects. IGBC AP is an accreditation program that we have. So an IGBC AP is one who will have a holistic understanding of what green building principles are. Around 1 lakh plus IGBC APs, considering the demand that we have. So we expect around 1 lakh IGBC AP to be there in the market by 2025. And right now we have only 5,000. So there is a huge scope for all of you to get this accreditation examination also. And before I close, very briefly, I'll talk about the IGBC mission on net zero. So as I was saying, pathway towards zero is very important for us. India as a country, we have declared to the world that by 2070 we'll be net zero. So for India to be net zero, the buildings, the operations, the factories, all of that also has been net zero. So to create a pathway for that, we have formed different rating systems on net zero. So first we encourage the project to go green, go net zero on that with respect to their energy performance. You can also do it from a water. You can be net zero on water. You can net zero on waste that is going to the landfill. And all of this will culminate into IGBC net zero carbon. So if you achieve all of this, you will by default be meeting the IGBC net zero carbon. So very quickly to give you an example, so this is our center of excellence, and after 15 years, we wanted it to be the first building in India to be completely net zero on modern day chiller. We changed the lighting fixtures to a more efficient lighting, the LEDs with sensors. We revamped our building management system so that around 8 to 10% of saving happens only because of the BMS, because our VFDs, our chillers are now more efficiently managed by the BMS system. And by reducing our energy intensity, we now minimize the renewable energy or minimized our energy consumption or EPI of the building. And once we brought down the EPI, then we thought of going in for renewable energy, which would offset our entire consumption. So very importantly, if you can see the screen here, we are very new technology called as a bifacial solar panel. So in this technology, what happens also and the phase behind it. So when light strikes on this panel, it generates electricity because of photoelectric effect. But if the light strikes here, which is now painted with SRI, that is reflective coat, it reflects it back and it hits the back panel. So the back panel also generates electricity. So effectively, with a small, small area, you are able to generate twice renewable energy as a conventional system. So because of this, we are now completely net zero. In fact, we are net positive. We give out electricity to the grid as well. So just to sum up, we are a bit short on time. I think I've exceeded the time also, so sorry for that. But to sum up, what I would like to say is that green buildings offer us an excellent opportunity right from day one to reduce our operative cost and also it provides us with a lot of intangible as well as tangible benefit. So if you can recall something like a Wipro getting 1 crore of tangible savings year on year. And all of this will lead to a long-term sustainable impact for you. And it also makes a lot of business sense also. If you look at from an industry point of view, from this more sense to you also. And green buildings also offer us a pathway towards net zero. So with net zero in it, the first step towards going towards net zero is to be green building. And once you are a green building, you have an option of going and converting your building to a net zero building. So with this, I'd like to end the presentation. And if there are any queries, I'll be more than happy to take it.
Yeah, thank you so much, Amith, for a very detailed and a very simplistic presentation so that our students could understand, and even the participants from all around the world could understand the benefits of green building and going green, how it is so much important. So there are certain questions for you which are there in the chat box. I'll just one by one present it to them. So first question is it possible to construct green building in a thickly populated area, town or city? And then probably it can be done only in a precise place. That has the first query.
Yeah, I mean, to answer that, so most of in India are fitted city, and the second largest is NCR. So to very simply answer your question, it is possible irrespective of climatic conditions, a green building. We have certified green buildings right from Ladakh, from Kohima in Nagaland to Kutch in Gujarat. So green building can be certified in each and every climatic specifications that is found in India or anywhere in the world. It also, I mean, doesn't depend on the density of population. It can be developed anywhere as long as you follow the principles of green buildings.
Yeah. And then another question is there any plan from government and to demolish the old conventional buildings to construct green building in near future?
Okay, so again, there could be various, I mean, there could be some, what is happening from a government point of view is that they identify certain of their projects. For example, all of you might be aware of the new parliament building coming up. So a lot of annexed buildings that were there, the older buildings, which could not accommodate the existing staff of the government of India. So those buildings are now getting demolished, and the construction waste that happens because of demolition is used for constructing the new buildings. And some of the main thing is that always demolition construction is not the best approach. We can look at whether the building core and shell can be retained as it is. If it is structurally strong, can the core shell be retained so that your demand on virgin materials come down? So just to give you an example, some of you can Google this Ambuja Cement Corporate Office in Gurgaon. So this is a project which is similar. Like it was a 22-year-old project when they thought of going and making it their corporate head office. So they had two options: demolish it completely and build a new building. And the second option was retain as many elements of the building as it is and only do changes to the interiors as well as the facade elements. So they took the second option. They retained the core and shell and maximum amount of structure elements as it is. They only looked at the facade. They changed a little bit of facade elements. They changed the interiors, and the building today looks better than a new building. So that is the option that is there. And it depends on the project specific details.
Yeah. One more query is there. How many successfully designed and cost-effective green buildings are in India, or their ratio relative to the conventional ones in the present scenario?
Okay. So to give you an example, so we have we have around 7,128 projects that are registered. And out of that, around 2,500 projects are completely operational. And all of them have a very successful case study to showcase. All of them have very financially backing tangible impacts to showcase for. So if you compare that with the overall knowledge, probably that might not be high, because 7,000 buildings compared to more than 2 lakh, 3 lakh buildings of stocks we have might not be high. But if you look at the impact that we have been able to make with the green building movement, in future the ratio of will start increasing. That means for every 10 buildings that is getting developed in 2022, probably 4 to 5 will opt for green building. And for every 10 buildings that constructed in 2030 onwards, probably 8 will opt for green building. So the ratio will keep on increasing, and eventually, once we have to be net zero, that means all of the building stock have to be either green or have to be offsetting the energy and carbons.
Yeah. One more question is, what is the difference between natural building construction and versus green building construction?
Natural
building.
You meant to say NBC?
No, natural.
There is
a term used, not.
Okay, the term. Okay, as I told, irrespective of your construction methodology, both can be green, as long as the holistical impacts of green building principles are taken into account. So even if you are constructing, if you are going for a natural construction, by default you'll be meeting a lot of things, and it might be a green building.
Yeah.
But in a conventional methodology, because of your usage of say maybe content with high material with a high recycled content, your use of very efficient chillers or renewable energy, you might still be a green building.
Yeah. Some questions from even YouTube watchers are also there. It's mostly about economy of the green buildings and earthquake resistant design of green buildings, which you have covered certain things, but to cover all of those aspects is not possible in such a limited
time frame. Really
yeah. One last question we will take. Do we get points in classification utilizing old material obtained from old structure?
Yes, so we do have 2 dedicated credit points. So one is called as the building reuse. So if you are, as I told the Ambuja cement example, if you do something like that, there is a dedicated point, or I think there are around 3 points for it. And there is also called as a salvaged materials. So for example, if you are using, say, a railway sleeper or some other, some other material, and instead of throwing that material, which is almost end of its life, you're refurbishing it and using in your building instead of going in for a virgin material. If you're salvaging some existing material, extending its life and opting to use that, then again there will be a certain point given to that also under the salvaged material category.
Okay, Amith. So once again, I'd like to thank you a lot. You have given in a very limited amount of time the crisp knowledge which you have given to all the participants. One last question has also raised up. Let me take this also. Scope of green building in earthquake resistant construction. Please answer about scope of green building in earthquake resistant structure.
Is again Okay. So again, so things that are related to opinions or that are related to the local, what do you call the regulatory aspects of it is per se not addressed in detail. What we're saying is that whether irrespective of in which seismic zone you are, as long as you are given the government approval, that is what we are looking at. So if you have relevant environmental clearance, if you have relevant clearances for that building, that is what we look at, but we don't go into the detail and then check whether the building is earthquake resistant or not, because we feel that due diligence is done by the local authority or that due diligence is done by the Environmental Protection Authority.
Yeah. So with this, I like now to introduce our second speaker, and we'll ask him to join for the presentation. So let me just introduce our speaker 2 for today, Colonel Shailesh Pathak ji. He is the co-chairman of IGBC Chandigarh Chapter, and he was the past chairman of CII Himachal State Council. Also, he is the CEO of Art and Glass Inc. Pathak sir is an army veteran and an experienced glass and penetration expert. He is a science graduate from Delhi University and has done business management from IIM Lucknow. He is currently placed as co-chairman of IGBC Chandigarh Chapter and immediate past chairman of CII Himachal Pradesh State Council. He is also an experienced photographer, an avid adventurer, and a motivational speaker. So we are honored to have Pathak sir with us, and I like to hand over the stage to Colonel Shailesh Pathak ji for his presentation on glass as a sustainable green building material. Over to you, sir.
Thank you, Tanmay.
Thank you, sir.
Thank you, Amith, and all speaker, Ashish ji. I hope you can hear me properly.
Yes, sir. We are able to hear you very nicely.
Okay, so I start my presentation.
Thank you for interacting with us again. At the launch, you had addressed us very nicely. Again, we are able to interact with you. Thank you to give your time for this presentation.
I think I'm not able to share. Let me try again.
Yes, now your presentation is coming, sir. Now you can just move to your PPT. We are able to see your Google Meet screen.
Okay, are you able to see my presentation screen?
Your Google Meet screen I am able to see. You can just switch to your PPT.
I've done that, and
okay. Maybe you can go to present now and present your entire screen. You might have presented only a window. You can just stop presenting once, and then go to present now, present your entire screen. Then whatever you will see, you will be able to see.
Is it possible? Are you seeing it?
Yes, now it's perfectly visible, sir. You may even just press the hide button so that lower bar will go off, and then.
Fine. But I'm also seeing my presentation through YouTube, but I'm not able to see my presentation on YouTube channel. Maybe there's some.
Now it's coming on YouTube also. We are able to monitor it. You can just please go ahead and it's coming there.
Fine. So. Thank you very much for giving this opportunity to me to interact so many students and honorable faculty. Though glass is a very unique product, and I still believe, as I was listening, Amith, there are a lot of answers to be given to everybody. So before I start my actual presentation, a word about my company. The Art and Glass is our company. We are more than 3 decades in glass. As of now, it's the most advanced glass processor in India. We do all type of glass work, architectural, decorative, furniture, automotive, and it's one of the biggest facility in Himachal Pradesh in the nation. We have 3 tempering furnaces, 2 laminating lines, 2 insulating. I don't know, students may not be understanding this, but as I go ahead on the presentation, they will get a lot of input, especially civil engineering and architectural students. And apart from our glass, we also have 2 other products like UPVC doors and windows under our company Green Fenestration Technologies, and aluminum and facade we do under our name Access Solution. So glass, it's a really amazing product. If you see a modern building globally, this is the most dominant material. You almost 90% commercial building you see covered with the glass, and nowadays in household also more and more glass is being used. So apart from beauty, it also has an optical functions, visibility versus privacy. The same material, we can provide a lot of privacy, whereas it is used in windows where we want to see beyond our four walls. And technically, this also does controlling the heat ingress to our building. It controls the glare or solar glare to our building. We can control sound also using glass, the sound which is entering through our windows and doors. Glass is safety glass, glass is security glass, glass does a lot of things. It supports building envelope as well. So as we are talking about green building, and the topic is it a sustainable green building material? Oh, very much. I believe, not because I work in this field, I believe this is a fantastic product through which we can create green buildings, we can save energy, we can save environment, so many things. So as I just said, thermal comfort, we stop heat entering, we allow light to come inside. Glass can be recycled nearly 6 to 7 times. Or in fact, if it is properly handled, you can recycle it any number of times. We improve our air conditioning because we stop heat entering the building through windows and doors. We can reduce our energy spent on daylighting or illuminating the building because it allows the light. Transparency is very important function. If our building is all around thick walls, no light entering, people start feeling claustrophobic. So by putting a glass without allowing anything, it gives a very roomy appearance to the building. As I said, it can control the noise, so it becomes very easy to stay in glass buildings. As I just said, it supplies natural daylight, it protects us from the vagaries of the nature like rain, wind and cold, heat, as well as sound. Minimum disturbance to the landscape and site condition. It doesn't affect whether we use doors and windows of any other material, wooden or anything, it doesn't affect. As I just said, we can recycle any number of times. It's the most environment friendly building material. We need not put it into landfill. In India, the clean glass is used number of times. When it becomes very, we can make a glass wool for insulation. We can do multiple things with this. This is non-toxic material. Whenever we talk about containers, glass containers are the best. We store medicine in them. We store every type of food in these things. Even solar panels also made using glass. So it is used in a renewable energy. Ideal indoor air quality, because glass is used in doors and windows. So we can also control indoor air quality using glass. So as some of the students were raising few questions, so slight information. My lecture is generally of a longer duration and a different kind of a thing, but still I try to give maximum information through this. So we can control sunlight, glare, or heat. So by controlling, either reflecting the heat back to the nature or reducing the ingress of UV radiation. We will talk about that. And in Himachal or in upper reaches of Jammu and Kashmir, in Ladakh, you must have heard they are creating a temperature in such a colder climate by using a transparent polyester sheet or a glass sheet. So we can control energy or a temperature or heat by glass. If we allow natural light is it's really useful for what otherwise called as sick building syndrome. Wherever a dingy building which is dark, not a sufficient light, if we put glass even at very few locations, which is allow the natural light to come in, it will really become a very happy building or a healthy building. Nowadays, glass has vast variety. I was just hearing Amith. Amith was saying radiation, conduction, convection. So we will talk. Using glass, we can stop radiation or reduce radiation. We can reduce conduction of heat. We can reduce convection of heat. So it's a fantastic product. And any building which may be designed poorly or not having a good aesthetics, if we add certain element of glass, in Hindi, it is like adding tadka to a dal. So by adding glasses correctly, we can really enhance our aesthetic of the building. All green building has a big share of glasses. And glass is the only material other than steel, which in 5 mm thick can give a lot of structural strength. So by using glass, we can reduce the weight of the building. Green glasses are also having many coatings, certain things like low-E coating, which I may talk today or we can take it to the further lectures. How we design the glass or how we select the glass. So appearance, thermal performance, and occupant's comfort. Another aspect of performance is controlling the sunlight, in turn controlling the thermal insulation. We can add a lot of colors to the glass. And then another parameter for which we select a glass is transparency. In bathroom, we want to keep a privacy, so we keep it frosted or other design pattern which doesn't allow people to peep inside. And then energy is always important, how we are saving energy on heating, energy on cooling, and amount of recycled content, and what all glass is available locally. So many parameters to select a glass. And when we talk about energy management, so key parameters are solar factor or solar heat gain coefficient. So in colder climate, we want more and more sunlight, but in warmer climate, we don't want the glare to come in. We don't want to heat to come in. And to select the glass, there's a value which we call it U value. It is a resistance to the heat transfer inside the building. We may talk later on. And then another is visual comfort. In mountains, if we have a very nice view from outside our windows, we want to have a bigger windows with more and more glass. I don't know how much of you, I believe it must be taught in civil engineering, or mainly it's an architectural function. So, can somebody asking?
No, it is taught, as you were saying.
Okay, fine.
These things are taught.
When we are talking about solar factor or a solar heat gain coefficient. So we plan orientation of the building. If our building is east to west, then southern side will receive sunlight whole day. If it is in a colder climate, it is fantastic. Our building will remain warm. And if it is in a warmer climate, then orientation is so important. If it is east to west alignment, south side windows will have so much heat, it will be really upset the calculation of our air conditioning. How much is the area of glazing? Same thing, if we want more sunlight, then our area should be more. So we see colors. When we talk about radiation, we can control the radiation by having the tint. Like in our sunglasses, we have a gray, brown, green. So similarly, if we use tint in the glass, we can reduce the radiation. Whatever amount of radiation we want to transfer, we can control using the tint in the glass. The glazing which we are fixing, is it for exterior or it is for interior? If it is exterior and you want to avoid heat entering inside, then double glaze is the most important. Right now, the image which you're seeing on the screen is depicting a double glaze glass, where there's a one external glass on the left side and internal glass on the right side. And then a lot of environment factor, wind speed, or wind or temperature inside, difference of temperature inside, outside, size of the building, size of the glass, so many parameters to decide solar heat gain coefficient or solar factor. U value, these are I've given here a thumb rules. They're not a calculation. So commonly, if we are using single pane glass, so our U value will be 5.2 watt Kelvin square. If we use insulating glass, that is 2 layer of glasses separated by a spacer, so it brings down the U value, or it improves the thermal efficiency of a glass to a great extent, nearly doubles. So U value, the smaller the U value, better the glass performance against heat. So if we have a double glazed glass, so U value comes down to 2.7. And if we add a coating, right now I'm not talking about tint or a colored glass, but we are talking about a coating like a reflective coating or lowy coating, then this double glazed glass, value will come down to nearly 1.2. And if we are using triple glazed glass, then it is much lower, fantastic performance, and we save a lot of energy on air conditioning or heating of the building. Generally, we heat buildings in colder climate, and in a warmer climate, we have to increase our air conditioning. And all these additional expenditure we spend on insulating glass or a coated insulating glass or triple glazed glass, by saving energy, the cost is just within 3 to 4 years, we can recover our cost. So here I've shown a double glaze unit. So 2 pane of glass are separated by a spacer. Inside that spacer is a desiccant where it is written a dry agent, and other side it is 2 glasses. The bottom one is a secondary sealant, which purpose is for providing the structural strength. It is 2 component silicon sealant. U value, as in a previous slide, I've shown single glaze, double Lowy, and then triple Lowy glass. Another aspects in deciding the glass is visual light transmission. The purpose is to illuminate the interiors as well as stop the heat. So if we are using low E glass, they reflect heat, but they allow light to transmit. So glass for a green building, there are a lot of options. One is multi-layer glazing. So as we just discussed, double glaze, triple glaze glass. Glass in place of grills. If in India, we need to provide a lot of protection to our buildings so that no intruder can get inside. If we put that old traditional iron grills, it increases the cost. Iron is a mineral, or iron ore is a mineral. So by having laminated glass, we can do away with grill. And presently the steel has such a high cost, so without spending much money, we can put insulated glass or security glass so that we can stop intruder inside. Earlier, or still right now, whenever we have to increase the thermal efficiency of the unit, we want to increase the spacer distance between two panes. But a new technology is coming right now. It is not proven. We cannot make a bigger glass, but it's a vacuum glazing. It works on the same principle like a vacuum flask. Another green feature of the glass is self-cleaning glass. So if glass is automatically cleaned, then we don't have to spend waste water for cleaning, spoil water using surfactant, soap, or a detergent. So on a clean glass, we do titanium dioxide coating or certain other proprietary coatings. Whenever sun falls on those glasses, those coatings become hydrophilic in nature, and dust and all, it just wipes the glass. Another material which saves energy in glass is phase changing material. So what it does during daytime, it absorbs the heat, and during night time when sun is not there and temperature is low, it re-radiates the heat inside the building. Another one is talking about low emissivity glass. If you know about energy spectrum, so a plain clear white light is having 7 colors called VIBGYOR, and in this VIBGYOR, the orange to red side of the spectrum is where more and more heat enters the building. So when we cut orange and red, we nearly cut 70% of the heat and allow 70% of the light inside. Though some other time when we have an actual classroom, I will come to your institute and talk about more on these features. Heat soaking test is a test which saves installation, and I don't know what to talk about right now. It is related with the breakage, spontaneous breakage of the glass, and then it's a safety after installing. Certain other parameter which I want to talk about is, you must have heard photochromatic sunglasses. The moment it has a more sunlight, it turns slightly grayish or a bluish. Similarly, we have an electrochromic glass, which we can control the heat and light entering the building. So on left side, you see quite clear. It is not 100% clear, but when we switch on the power, electricity, it turns clear glass, and when we switch off the power, it turns tinted. Some of you must have seen these windows in the Dreamliner aircraft. So a few other smart glasses are suspended particle device glasses, and in which we do If it is power off, it becomes frosted, and the moment we supply power, it becomes clear. The clarity is somewhere around 60 to 70%, not 100% clear. Another type, or another technology for a similar kind of a performance. And then there are microblinds. These are not very popular, but have been designed and expensive to control. They control the light or heat entering inside the building through glass blinds. Glass as a green material is also used along with integrated photovoltaic cells. So here you're seeing a railway station in Germany where the complete roof is made photovoltaic integrated glasses. So to control sunlight or a strong heat, we have movable sun louvers of the glass. So they are building management controlled by building management system. They move along with the sun direction. And those glasses, we can control the amount of sunlight entering the building by increasing or decreasing this dot of opaque material. If we increase the size, right now what you're seeing is around 75% light inside and only stopping 25% by having these dots. If we increase the size, just double it, it will become 50%. And by increasing further, we can control the amount of light entering. Then these are the glass cells. What happens in a building? Anybody who's sitting closer to the window will get sufficient light or sometime more light. But people sitting inside may not be having sufficient light. So glass louver, they reflect the sunlight, and using the roof for reflection, they take the light further inside the building. Another picture. So I think you will get how glass is used for carrying the light inside the building without increasing the glare and reducing the expenditure on the electricity lighting. If your building is designed in such a fashion that you receive sunlight on roof, but it is not carried to the lower floors, so we can have glass floor which will transmit the light in those areas where light is not there, natural light is not there. Another very good is in between the glass blind. We'll not talk about right now, some other time. So this was my take on glass as a green building material. So if you have any other questions, I'm open to that. Thank you very much for listening.
Thank you so much, Colonel Shailesh, for this very wonderful presentation, and with very in a simplistic way and in a very generous way, you have talked about a glass as a sustainable material. So there are certain questions from the chat box and the YouTube. The first question is, which is better, heat resistant glass or simple glass with heat resistant film? Which will be better option for green buildings?
Say again, heat strengthened and?
Heat resistant glass versus simple glass with heat resistant film.
Film is generally made using a polymer. So it's a very short-term option. The film will last 2-3 years, and thereafter it may come off. It may lose that efficiency. So actually, the glass is a better option. It will continue for so long.
Yeah. One other query was, can we use translucent concrete at the use of glasses instead of use of glasses?
I'm really sorry. I've never seen or heard about translucent concrete. So I believe if you have to make a window, you cannot make using translucence this thing.
Yeah.
Glass we use, but if this product, whenever I see, if it can be made in that part, we can use it in place of fixed glass, but not open it.
Not open. Certain bricks people are making with translucent concrete nowadays, certain kind of translucence properties, but not as clear as glass or with the usability as you have explained to us. That is going on. Even one of my query was there, what are the certain aspects in glass design which are going in research right now or are more popular amongst the researchers? What kind of products or what kind of properties they are wanting to induce in glass?
The thing which I call like phase changing material that will absorb the heat during daytime in a colder climate and re-radiate the heat inside. Though there are phase changing material available, but their efficiency is not so good.
Okay.
So people are working on them. This vacuum glass is also available, but it is still in a smaller size. We cannot make a bigger windows using that. So people are still working on them. When we create a vacuum, both the sheets come together and join, which defeats the purpose of which conducts the heat. So a lot of research is going on in those areas.
Thank you. Another question has risen up. How color-based glasses is recycled?
Okay. Colored glasses, like any color, it is recycled into a container. If you see medicine containers or a small bottles having a dark or a green shade, those are meant so that internal medicine or whatever is kept inside, the material kept inside those is not bad, doesn't get bad because of the UV radiation. So our medicines are generally in the brown bottles. So whenever we recycle clear glass, and every time we recycle, the tint color is increasing. So when it becomes number of times, then we make a dark colored glasses.
Yeah. One of the queries was when we are planning common apartments, which type will be preferable for glass?
It depends. Mainly in building, everybody will understand we spend 60% of energy on controlling the temperature. In a warmer temperature, air conditioning takes nearly 60%, and in a colder climate, heating takes 60%. So our main problem is of heat control. So double glazed glass is the best. Almost 90% commercial buildings are designed in double glazed glass because office buildings are never switched. The air conditioning is always on. If it is a 24 hours working, air conditioning is never switched off. If it is a data center, we spend 90% amount in controlling the temperature because all these computers or a data center generates a lot of heat. So double glaze or a triple glaze or insulating glass is a correct type of glass.
Yeah. Again, regarding the manufacturing process, is it eco-friendly to manufacture such glasses?
Oh, fantastic. Firstly, glass is just sand, silica. It's a natural, whatever you see along a sandy beach or on a riverfront, everything is heated at a very high temperature. It turns into clear glass. So there's nothing which spoils the nature, nothing. It's naturally given by the God. And when we make a sheet, then it is a processing or assembling a sheet in double glaze or a triple glaze. So it doesn't waste much of a nature.
One last question we will take. Is reinforced glass is preferred in the buildings?
Which glass? Sorry?
Reinforced glasses. Reinforced glasses, if you are able to hear me. The glasses which are reinforced, maybe with bulletproof nature.
Those are not an architecture glass. The reinforced, I really don't understand what is by reinforced glass. Why, if we have to make a strong glass, we increase the thickness of the glass. And if we have to increase the strength against bullet or strength against windstorm, we use laminated glass. So we add number of layers of the glass using certain polymers to bond them together. So and that is not called as reinforced glass. It is called laminated glass.
Yeah. One comment is there that manufacturing of glass is high energy intensive. Can you comment on this?
Oh, sure. But best thing is every product, steel is highly energy required. To making a steel, also we have to increase the temperature to a certain. But what is the best about glass? It's a continuous process. We keep on adding raw material, and furnace is never off. So if furnace is off, it will require 500 crore to maintain that glass. So every product requires energy to make. When we produce food, we produce for a 1 kg rice, we nearly use 4,000 liter of water. So for making a product which will save a lot of heat or a lot of energy, so it's okay. Yeah. I believe every product, whether it's a cement, whether it is steel, they all require a lot of energy to produce.
Correct. So I hope that answers your queries regarding the energy intensity. So again, as sir has enlightened us with the uses of glass and the eco-friendliness of the glass as a construction material and how it can be utilized in so many different forms. So again, we will be very honored to host you, sir, at Jaypee University, physically also to come here and deliver your full lecture on glasses sometime as in future things open up. That will be a great learning experience for all of us.
Thank you, Tanmay. Today lecture was totally from my side. It was academic. Yeah. Glass as a green building material. I don't know how much students get benefited, but in a next lecture, when we will have a face-to-face in your university, we can tell them how it is done, how we plan for a double glazed glass, how we plan for a laminated glass. So a civil engineer or an architect then will understand what is his role in selecting a glass.
Yeah.
So we will do on some other time. Today, it was a green building seminar. So glass is very much green, and I will request Amith ji, radiation, conduction, convection, glass can stop all those three things. And a metal, if I make a surgical knife, I will use it against disease. If I make a military sword, I will use it against enemy. And if I make a knife for a thief, so it is the product is not bad. How we use that product, it depends on that. So please do not mind my comment, Amit. But we need to discuss how glass, why whole world is making glass building, why Apple showrooms are in glass, why your building has a lot of glass, this Hyderabad building, why solar panels are in glass, they can also be made in plastic. So there are reasons. It's a most sustainable product. It can be recycled number of times, and all those uses or related issues can be handled.
Yeah, that's a great comment to end your session, sir. Thank you so much.
Thank you very much.
Thank you, sir. With this, I'd like to introduce now our third speaker for the day, architect Shelja Gupta ji. She is the principal architect for Design Earth. I'll just briefly introduce her. Just give me a minute to present her slide. She'll be speaking on urban green buildings, the new address of sustainability. Shelja Gupta ji is an established architect with an experience of more than 22 years in the field of architecture. A firm believer in the philosophy of study nature, love nature, stay close to nature because it will never fail you. She has been inclined towards sustainability from the very beginning of her career and has consistently aimed to transform the future of buildings to a greener tomorrow. Her professional journey began in 1999 upon graduating from Chandigarh College of Architecture, CCA. By 2002, having gained some years of work experience, she established her architectural studio, Designing Earth by Studio Bhumi. Over the years, she has gained widespread practical experience in planning, designing, and development of architectural projects involving commercial, institutional, residential, society, and industry projects. She skillfully articulates her sense of style into various elements of design in all her projects, creating its own character in harmony with the surroundings. She perceives a building not simply as four walls, but as creating a character that is customized solution for each project. She strongly believes that each design should fit holistically into urban fabric yet stand out in its uniqueness. She is continuing to weave her dream every single day, countering the threat of concrete jungles by creating wonderlands of sustainable architecture that will be cherished for the generations to come. With these words, I like to invite Shelja Gupta ji to virtual podium and present her topic, Urban Green Buildings, the New Entrance of Sustainability. Welcome to you, ma'am.
Good afternoon, all. I'm overwhelmed to be on this, dais, and I'm really thankful to Jaypee University, Tanmay, especially giving me an opportunity, and IGBC for giving me this opportunity to come here and, talk about it. I was continuously listening to whatever Amith has been talking about and Colonel Shailesh were talking about. And, the first thing that I wanted to request Colonel Pathak immediately was, Sir, हम आपकी फैक्ट्री चलते हैं देखने के लिए कि शीशा कैसे बन रहा है. That's the spot, actual learning ho sakti hai, and especially for, all the younger generation, because that is from where you actually start to understand the process of manufacturing of glass, because that is one of the key important, elements in our construction energy today, in our construction sector. So I'm going to talk about, because most of the topics that in any case I had to talk about have already been covered. So I would start with probably one of the case studies, which is very close to my heart because it is a platinum rated building. So I'm going to start presenting my screen. So is my screen visible?
Yeah, now it's coming.
So I'm going to start from here. Urban green buildings. So, one of the key things that we were always answering was, can urban buildings be green, or it is just implied to, rural things only? So I think you have said enough about this. So I'm not going to talk about this. So we start from here directly, start with the case study directly. So I'm going to present a project which is a residential group housing where we are housing more than about 140 units to the bedroom size of about 4 BHK each. And that's a pre-certified platinum rated building. So first things, which we were always asking about, and I think these questions have already been answered by Amith. So I'm not again going to talk about this. Why build green, basically what is a green building, importance of green building, objectives of green building, benefits, who will it profit? Because eventually, triple P is very important. So profit for everybody is very important. So I would start, directly from here, that why we thought that exotic should be a green building. So this journey with exotic grandeur started in about 2014. So 2014 की अगर हम बात करें, हमारे region में जहाँ से हम हैं, चंडीगढ़ and Tri-City, कोई green buildings का concept नहीं था. So we wanted to be, a pioneer in this segment, and we wanted to launch the concept of having first ever green homes. So the intent was that this particular, development would change the concept of living in the city. It would probably give everyone at that time, the way we were constantly discussing it between all the stakeholders and our contractors, that it will give a better living environment and it will help us to promote, sustainability. So the intent was that if we are talking about a green building, the elements of luxury have to come along. So we can't talk about, just something which is not luxurious. So we started, and we started to talk about that what could be differences between a regular group housing, which we all see around us, and what would be the difference between luxury green homes, which are actually green homes. So what we are talking about is a luxury green home. So we thought, and we took, and when we decided, so okay, let's start and pen down what is it that we can do. So we started with this, that okay, let us first try and understand our responsibility towards our environment. Let us opt for sustainable building. Let us see what we can do. So we started to do components like, we were thinking about components like waste segregation, rainwater harvesting, dual plumbing. We have to maintain indoor and outdoor air quality, reduce heat island effect. And the important thing then, basically what happens is कि building तो बना दिया, but अगर building बन गया तो residents को उनकी responsibility के लिए aware करना is one of the larger tasks, which as a developer, Exotic Group thought that we should be talking about. And then, making judicious resources, use of our resources available to us. So see, it's not that, green buildings cannot look luxurious. This is the actual photograph of Exotic Grandeur, which was taken in the year 2020. So Exotic Grandeur is the only project in this region. This is a 6-star, CRISIL 6-star rated, and as well as, certified from IGBC as a platinum certified building. So the journey started from the concept of choosing the site. So as Amith has already said that this particular rating system that I am talking about contain multiple kind of components. हर component को जब हम address करते हैं तब वो journey के लिए हमारे platinum के लिए points पूरे होते हैं. So I will just talk about this, that to cover up this journey. So green homes, the rating system gave us an evaluation on about 100 odd points, which are divided into credit scores. The complete collection of credit scores, if we cross above 80, would qualify us for a platinum. So we started our journey, and we told it to ourselves कि हमको कुछ भी हो जाए 82, 83 points तक तो हमको काम करना ही करना है, so that we have to qualify for platinum. So see the location, the way the buildings have been placed. So this particular orientation on the site plan was very, very important, because what happened, it allowed lots of sun to filter into the building, and the central landscape plaza allowed the air to cross, and it allowed for us to ventilate all our apartments in a very beautiful way. So these are, certain more pictures. So the first picture is basically when you are entering into the building. So once you enter into the building, so what we have done is there are, these landscape podiums. As you can see that there is lots and lots of vegetation complete all around the building. The water that you see in these water channels is completely recycled. Here also on the next picture, which is an evening view of the water channel, the water that we are using in the channels is completely recycled. And the lighting that you see on the facade or wherever it would be, it is all complete LED. The complete project has not even used a single light, which is not a LED lighting. So these were the green building parameters on basis of which, we divided. So this division is done as site selection, water efficiency credit, energy efficiency credit, material and resources credit, indoor air quality credit, and then innovation and design process credit. A collection of all of these credit scores helped us to gain platinum. So for example, I would just share very, very small components and very small points that what helped us to do this kind of a site selection and how we achieved credit points in that particular category. So for example, there was an option of picking up between two particular sites when we wanted to start this project. So the developer had two sites in mind. So why this particular site was chosen was its proximity to educational institutes, healthcare infrastructure, recreational areas, utility stores, places of worship. अब रेटिंग सिस्टम कहता है कि हमको 800 मीटर वॉकेबल डिस्टेंस के अंदर ये सब चीजें चाहिए. So we thought कि उसका एडवांटेज क्या होगा? The larger advantage now is that actually what happens, for example, I want to go to mandir every day. So now going to mandir would have been a task for me. अगर मेरे को गाड़ी उठा के रोज गाड़ी स्टार्ट करके 4 किलोमीटर दूर मंदिर जाना है. But here in this case, the mandir is just within 500 meters. So that means कि घर से उठी मैं पैदल गई और पैदल वापस आ गई. So same goes for so many other things as well. For example, the proximity to the school. So that means that, the owners and the final, occupants of the building do not have to go actually far off to send their children to play schools. So which would mean that every time they are not going to turn on their car engine, and then, they can just completely and very conveniently just walk around the premises. And that invariably has helped us to reduce carbon footprint, of the complete project. So then a larger thing was that we wanted to be ready for the future. So thus we decided that whatever would be there, we must prepare ourselves for future, though in the year 2014, the complete idea of electric vehicles, of course. Now what we are talking is 2022, and we have already seen that, there are so many hybrid vehicles now which are already there, and, the complete world is heading towards electric vehicles. So thus we are future ready. We have made enough provisions that, for example, the developer would have, a car which is an electric car. They don't have to think, and they can probably just come and plug, their vehicles. Just a second, I'm just trying to go to the next slide.
You can press hide on this, maybe.
Yeah, I can press hide. So we are ready with, complete more than 5% of total parking slots that are there are already, more than 5% of the total parking slots in exotic grandeur are equipped with electric charging. So these are some heat mitigation practices which have been adopted, at exotic grandeur, where we have done dense vegetation all around. We have used, grass-screened pavers. We have done covered parking, because अगर parking खुले में रहती है तो obviously उसके नीचे बहुत सारी गर्मी के हो जाती है. हमारे पास option थी to use ordinary pavers, but we decided that okay, let's not use ordinary pavers and let us use grass-screened pavers, so that at the end of the day, there is amount of rainwater, water is going into the whole, ground, and invariably the concrete top is not there. So this is looking like, a kacha green belt is available to us. So these are a couple of other things that we have done. We have done landscaping on roof areas, grass-screened paver is there, and major areas which are there inside our building are planned with drought-tolerant species. इसका मतलब है कि जिन पौधों को पानी कम चाहिए, हमने वो वाले पौधे लगाए हैं. So हमारा landscape consultant for this particular project is Oracles, and the architect for this project is IE Design New Delhi. So, on the day one, all of us were working together to set a goal that okay, जितने हमको पौधे लगाने हैं project में minimum turf areas होने चाहिए, because actually जो सबसे ज्यादा पानी लेता है. So we decided minimum turf areas and maximum amount of drought tolerant species. So then we come down to water efficiency. In case how to develop water efficiency, just give me a second. Jyoti ma'am को अंदर बुलाइए please. So then to achieve water efficiency for this particular project, so what we have done is 100% of the rainwater that is dropping, and every single drop of rainwater that falls in this particular site area is what we are trying to kind of we have a complete drainage system which is collecting all the rainwater, and the complete rainwater is getting discharged into the ground. So we are recharging the complete ground with all the rainwater collected. Then we are using water efficient plumbing fixtures in the complete project. The complete project is equipped with dual plumbing. Now let me explain you what dual plumbing is all about. So basically dual plumbing is leaving provision for leaving allowance in the plumbing lines, and leaving provision for the fact that the complete recycled water through the STP will be used for our flushing requirements. So which means that the complete project is equipped with the fact that the STP water is being treated at site and is being used for landscape, and the residue of whatever water is left after being used for landscape is being used for flushing requirements. We have used low flow fixtures. We have catered to the fact, one understood that, Amith also very, specifically he was talking about water saving for all the green building projects. So we understood कि हम एक टैप के थ्रू पानी कैसे बचा सकते हैं. So the challenge was, हमने क्या करा, rather than taking a tap or rather than taking a WC with an ordinary LPM or a LPF. So LPM is basically liters per minute or liter per flush. So we took up fixtures which were actually water efficient from day one. So for example, a regular LPM of 6 is what is considered as a baseline case in case of IGBC. But for this particular project, we decided to go as low as 4.5 LPM or 4.2 LPM so that we can achieve a saving of about 20 to 30%, whatever maximum we could target for each zone, by using just a low flow fixture only. So for the complete project, as what I told you earlier also, we have used drought tolerant species जिनको पानी ही कम चाहिए है. For the complete area, drip irrigation system has already been installed. So हमने देखा है, एक जनरल प्रैक्टिस है कि जनरल प्रैक्टिस के अंदर क्या रहता है कि हम पानी की पाइप लेके पहले जमाने में, और हम अभी भी काफी जगह देखते हैं, पानी माली देता रहता है. अब उस केस में क्या होता है, माली को पानी देने के लिए पानी चाहिए होता है पौधे की जड़ को, माली पानी देता रहता है हवा में. So which means that it leads in lots and lots of loss of water. So an effective drip irrigation system also helps in saving probably to a figure of about, again, more than 25% of water is what we can save in the irrigation by just using drip irrigation system. Then we have used, so this word over here is not motion sensor, it is moisture sensors. So we have installed moisture sensors in the building, in the complete landscape zones. अब मॉइस्चर सेंसर का मतलब क्या है, हमने ड्रिप इरिगेशन सिस्टम को तो ऑटोमेशन पे कर दिया. अब ऑटोमेशन में जो हमारा टाइम सेट था, लेट्स से वो 6:15 बजे का सेट है कि 6:15 बजे रोज शाम को मेरी ड्रिप इरिगेशन की लाइन जो है वो चालू हो जाएगी. अब वहां से बारिश पड़ रही है, अब ऑटोमेशन को तो ये समझ में नहीं आएगा कि बारिश पड़ रही है. सो दैट इज व्हाई मॉइस्चर सेंसर्स प्ले अ वेरी इंपॉर्टेंट रोल. सो मॉइस्चर सेंसर वुड ट्रिगर द सिस्टम बैक, एंड ओनली देन if the soil actually needs water, the drip irrigation system would turn on, and all of these services are completely on automation. So we have used 100% of our treated water in the landscape. 100% of the sewer generated at site is being used and is being recycled at site only. So the STP installation done at site, so STP is basically sewerage treatment plant. So STP installation done at site is equipped to 100% of the requirement that is being generated at the site. So next, this is the landscape layout. So as you can see, whichever nook and corner of the site we could get. So whether it was under a porch, whether it was a car park, whether it was, any kind of a zone that we got, we thought plant a tree, plant a tree, plant a tree, plant a native vegetation tree. Rather than doing, घास, because घास लगाते हैं तो अगर टर्फ रहती है, टर्फ की water requirements बहुत exorbitant होती है. So we have used turf, but obviously in the limited zones only. So we decided and worked on a landscape plan in the very basics only, as a very basis of design with, our landscape consultant, that we will use maximum areas as vegetated and we will use minimum areas as turf. So these are our rainwater analysis. So it is not कि हमने ऐसी हवा में बात करी कि अच्छा ठीक है हमारा इतना पानी इकट्ठा होगा. पानी इकट्ठा करने की भी सब सॉफ्टवेयर कैलकुलेशंस हैं. So based on that, there was rainwater calculation data sheet which was made on the basis of the data which has available on IMD website for the last 3 years. जिसके बाद हमने सारा डाटा कैलकुलेशन करा कि हमें कितनी पिट्स चाहिए है और हमारे को कितना सारा रेन वाटर का पानी है जो किसी भी वर्स्ट केस सिनेरियो में इकट्ठा हो सकता है. So just by opting for those small measures, we were able to achieve a saving of about 35% odd for this particular project. Now we talk about next step, which is energy efficiency. So to target energy efficiency for this kind of a project, so what we did was we installed complete solar water heating system. 100% of our common area lighting is on solar renewable. So which means कि जितनी developer के पास common areas की lighting है, that complete lighting is on solar renewable energy. सिर्फ LED lights use हुई हैं पूरे के पूरे project में. Street light sensor based है. जितनी street light landscape में, जितनी landscape की light और जितनी street light है वो photometric switch के ऊपर और सारी की सारी sensor based है. We used to often complain, 10 years back that okay, street lights are turned on even in the time of the day. Why? Because those systems were not automated and photometric switches were not installed in, those kind of gears. But now for automation processes are available. These kind of products are available in the market, and that's what we have done. So by optimally using our, street light, अब वो क्या होता है एक lux level के बाद जैसे ही आपका day light कम हो जाता है, then automatically the street lights turn on. So for this, we have only used complete CFC-free air conditioners. All the air conditioners used in the entire project are BEE 3-star air conditioners. ग्लास के बारे में तो आई थिंक मतलब बात करना अभी सही नहीं होगा बिकॉज शैलेश सर ने ऑलरेडी इतना बढ़िया हमें ग्लास के बारे में बताया है. तो मैं सिर्फ एक बात बोलूंगी कि हमने इसमें यहाँ पे जो ग्लास यूज करा था वो लो SHGC का DGU ग्लास था. बिकॉज DGU ग्लास से हमें बहुत बेटर एनवलप की एफिशिएंसी मिली और हमारी जितनी बिल्डिंग थी द कंप्लीट बिल्डिंग was actually constructed not by bricks but by using what we have used for the complete project is ACC blocks, so which actually have a recycled material in them. अब उसका प्रोडक्ट का जो एडवांटेज है लार्जली वो ये एडवांटेज है, waste for somebody else, so waste for another industry which is fly ash became usable for another industry to make a brick. So that's why we have used ACC block, which helped us. A, it was a recycled product. B, it helped us in having a better U value than what we would have got by using brick. So see, these are the exterior lighting. For example, अगर आपका lux level एक particular level के beyond drop हो जाता है, only these lights would turn on and off depending upon the requirement, and this is what had helped us to conserve energy. So ये छोटे-छोटे से features को opt करके we were able to save approximately about 15% energy in the exotic grandeur group. Our target was actually, to tell you honestly, we wanted to go beyond 20%. But unfortunately, rooftops were not available. We wanted to install a larger renewable energy plant at site. But as we understand, कि बहुत सारी जो rooftops थी वो हमारे water tanks ने ले ली थी. Then we had, already installed renewable solar water heating के लिए. तो जितनी balance हमारे पास छतें बची थी, हम सिर्फ उन्हीं छतों पे थोड़ा सा ही renewable energy के लिए plant लगा पाए, and we could only cater for our common area lighting. Now, this is for our next credit, which was material and resources. So we have generally, a brief conversation about site. We have done a brief talk about water. We have done a brief talk about electrical. Now, अब larger एक component आता है कि हमें बहुत सारा building material जो है वो use करना है. A building material quantifies to a whole lot of energy that is being used to make a building. So what we decided was, okay, so this is first thing, which is of course the mandatory requirement also, and then we wanted to opt for it कि जितना waste site पे हमारा generation होगा even after the occupancy. So what I'm showing you pictures are after the building is being occupied by its final users. So what we have done is we have tried to talk to all our end users कि भाई साहब कचरा नहीं लिया जाएगा अगर आपकी segregation of waste site पे नहीं होगी. So we want कि segregation of waste आपकी first step पे ही हो. हमने एक composters की installation करी है जिससे हमारा सारा biodegradable waste जो हमारे घरों से generate होता है वो सब कुछ site के ऊपर ही हम तैयार करते हैं और उससे जो खाद निकलती है that is being used, that compost is being used on site only for the complete landscape requirements. We tried and we were able to use and finally achieve a figure of about more than 40% of locally available materials for the complete project. सारा material locally available नहीं हो सकता और ये हम सबको मालूम है. So our target was जितना हम maximum कर सके. So for example, within our site radius of about 400 kilometers, we decided and we pinpointed, and allocated those particular industries. For example, cement की purchase थी, हमारी steel की purchase थी, blocks की purchase थी, कि हम सारा का सारा कुछ जो है वो 400 kilometers के अंदर ही ले. The wood that has been used for the project to a large extent has been used only from those vendors which have forest steward councilship, verifications. So most of the product, most of the wood that has been used in the project carries certificates from FSC, vendors. Whatever material, as what I spoke about, fly ash, bricks that we had used, ACC blocks that we had used, a lot amount of glass, tiles. So most of these products that we had used in the making of, the complete housing project have some amount of, recycled content in them. So waste segregation. So this is, for example, a picture जिसके अंदर हमारा जो waste है वो साइड से कैसे जनरेट होता है. ये डबल डस्टबिन पड़ा हुआ है हर फ्लोर के ऊपर जो डेवलपर ने प्रोवाइड करा है और कचरा ऐसे उठाया जाता है. ग्रीन का अलग में जाता है और ब्लू कचरा जो है वो अलग में जाता है. कंपोस्टर्स एट साइट. फिर उसके बाद हम आ जाते हैं इंडोर एयर क्वालिटी, बिकॉज अमित जी ने भी इसके बारे में बात करी कि 80% ऑफ द टाइम जो है हम लोग अपना अंदर ही समय बिताते हैं. देयर आर so as per the studies done, 80% of our time spent in any kind of a building is indoors. So the larger intent was to use products which have low VOC. So VOC is basically volatile organic compounds, which is a gaseous emissions that happen from a product typology, whenever the product is being used. So for example, the choice of the paints, the choice of the adhesives that was done to, be used for the project. Eventually we made sure that, okay, whatever kind of product that we are using has to have a low VOC. And low VOC eventually ये नहीं है कि मैंने बोल दिया low VOC और हो गया. So low VOC की proper certificates हैं, third party labs हैं जो tests को conduct करती हैं और उन certificates के basis के ऊपर ही product approve होता है as a low VOC material. We made sure when the design of the building was in the process with our, architect who had really supported us to achieve, this final goal for us, that the complete building should have maximum amount of cross ventilation and maximum amount of daylighting has to be achieved for the complete project. As what I have told you earlier also, that the air conditioners that were used for this complete project were all chlorofluorocarbon free. So we have only used air conditioners which were minimum 3-star rated and supporting only and only green gas. So this is a complete no smoking premises. All in the complete common areas, no smoking signages have been installed throughout the project so as to make sure that nobody is fagging around, while taking a stroll or a walk. So these are just some of the signages, which are being, because actually जब तक आप educate नहीं करोगे अपने end user को, उसको कुछ नहीं पता रहेगा. अब ये चंडीगढ़ में एक नॉर्मल प्रैक्टिस है कि जो रिसाइकल्ड वाटर है हमारे यहाँ सारे पार्क्स में और सब जगह रिसाइकल्ड वाटर की लाइंस एडमिनिस्ट्रेशन ने दी हुई हैं. बट बहुत बार ऐसा होता है कि आर मेड्स दे आर सिटिंग इन द लॉन एरियाज, तो वो लोग जो ये पाइप्स होती हैं इनके पास जाके पानी की बॉटल्स को रिफिल कर रहे होते हैं. So there are so many times, we go and talk to administration that, okay, unless and until there are signages there, they will not know कि यह पानी पीने योग्य नहीं है. So to educate the end user is very, very important. So this is what we are doing at Grandeur. So now just showing you an analysis, which is a computer generated analysis to calculate something which is called as daylighting. So we did these, simulations on the computer, which helped us to understand that, okay, more than 95% of our regularly occupied areas were achieving more than 110 lux at any given point of time. So this analysis has been done to support all those documentation. Plus, it gave us, that confidence that at any given point of time, if it's a nice bright daylight, we don't need to turn on our, lights, and eventually it leads to incredible saving. So this is another analysis that I'm just trying to show you. So with this, We will almost come to the end of the presentation. These are just some final pictures of the project. So see, it's a complete grand and complete luxurious segment of, residential living that we are talking about. So green does not mean that you need to kind of, build with straw or build with, those kind of materials which actually are like bamboo or something like that. But green can also be introduced in luxury. So green, this is what we are trying to talk about here, that it's a luxury green home that you are entering into. So see the presence of, a cinema hall, the presence of a pool. So with that, what happens now, the final occupants at the end of the day, so they don't need to go out to use any gym. It's a grand, big clubhouse that is already there, so that, the occupants can just walk down to have probably, just relax themselves, enjoy themselves. So for all the entries to all the towers, so there is a water feature that has been done. So that, the water feature, whenever you are taking a stroll or whenever you are walking down, so water feature with these native, trees. So for example, there is a whole lot of, vegetation that has been planted all around. So Conocarpus has been planted all around the periphery. So that, Conocarpus would probably, it has done a beautiful barricading of the complete site with respect to the other neighborhood areas. So similarly, if you would see, there is a whole lot of, चांदनी लगी हुई है project के अंदर. अगर हम देखते हैं, बहुत तरह का हमने जो हमारे इस region का native trees हैं, बहुत सारे trees को लगाया है with water features. So as you know, a separate climate and a microclimate can be created while taking, an evening walk in this kind of premises. So I think that's about it. So with this, I would like to end my presentation.
Once again, we thank you, ma'am, for giving such a wonderful and practical presentation. All of us academicians may give certain examples from some book, or we can talk about the concepts in theory, but you are doing it for years and showing it practically that green doesn't mean you are living in a kutia. It is a luxurious resort also you can make out of it and be environment friendly at the same time. So there are certain questions to your session, if you can just answer them. First is, have you faced any regulatory problems from some governing bodies in doing this project?
Initially, see, there is no, because as what, Amith has also said, that most of the guidelines that has been made by the council are already in aligned with all the norms that, MOEF is trying to say, PCB is trying to say. So thus, there were no regulatory problems from anybody, because what the regulatory bodies are saying. So we have started actually to do little more than that. So for example, they were saying, okay, अगर आप इतना पानी ट्रीट करते हो तो सही है. हमने तो उससे ज्यादा करा. MOEF की गाइडलाइन हमको कह रही थी कि अगर आप 300 पेड़ लगाएंगे तो बहुत है. तो हमने तो 400 पेड़ लगाए. So we have gone over and above whatever the basic guidelines have been set by all the government bodies to achieve platinum rating.
Yeah. So any clearances you need to take before that?
See, all the basic guidelines, all the basic clearances you have to take before applying to the council also for any typology of a rating building. So the council also needs to understand that, okay, मेरे project के पास pollution control board से already NOC है. NOCs तो आपको सारी की सारी चाहिए है before applying for any kind of a certification program.
Correct. There are certain questions from YouTube also that how to convince the upland farmers to maintain the watershed to provide efficient water supply to the different uses, particular to the farm irrigation and why?
See, मुझे farming lands के तो मुझे नहीं पता कि उसमें drip irrigation कैसे valuable होगी, but हाँ, if it's related to any urban landscape, then I can of course talk about it. Because drip irrigation systems are of course being used by many farmers, and especially when we talk about polyhouses. So most of the polyhouses that are there are always talking about drip irrigation systems only. But when it comes down to open land farming, most of the people still like to use a tube well, because it's a larger area and the cost of drip irrigation probably, see, we all understand that farmers are hardly making any profits, already. So I don't think farmers would want to probably open acres and acres of land, lay the process of drip irrigation. I think Shailesh sir wants to contribute something.
Yes, please.
Ma'am, all progressive farmers in areas where water is scarce are using drip irrigation.
Yes, sir. But in open farms, it is very difficult to tell everybody to kind of, go in for drip irrigation systems.
I have a feeling that farmer is not keen to understand. Otherwise, government is giving lot of subsidy for these modern irrigation systems. And if we see in longer run, they are not very expensive. So it is an initial one-time cost. Like right now, nationwide, government is giving solar pump at nearly 10% of its cost, and still government has to advertise in a newspaper so that people come forward and install them.
Yes.
So it's a problem of farmer, not of a technology. No technology is expensive in longer run. It is always beneficial. So in Rajasthan, Madhya Pradesh, even in Himachal, everywhere drip irrigation is a theme, because in mountains, water scarcity is very unique. Hardly any water available.
Yeah,
So,
there is some water.
Gee, so I don't think if somebody is asking it is expensive, it is just not expensive. It is, if we see the total cost of water storage and using, he did nearly at the root. So
I would agree with Shailesh sir. What Shailesh sir is saying, actually सब चीज की ROI निकालनी चाहिए. हमारी एक बहुत जो बेसिक कंपोनेंट होता है, हम ROI की बात नहीं करते और हम एक बेसिक प्रोडक्ट कॉस्ट की बात करते हैं. पर जब आप ROI निकालते हैं किसी भी चीज की, तो हमें पता चलता है कि प्रोजेक्ट की जो कॉस्ट है वो कुछ भी नहीं है. अगर उसका पेबैक पीरियड ही सिर्फ 2-3 साल है तो क्या फर्क है?
The same thing has been even pointed out for the green building setups for 1 or 2 story apartments, not for commercial buildings. Like what will be the return period if we are building with sustainable materials? If you can comment on that. So
just come again with the question, sir.
That if we are making 1 or 2 stories house for a common man using sustainable techniques, what will be the period of return in the investment?
So see, now the thing is that sustainability by itself is a very vast area. So there are so many parameters which would make a complete home, sustainable. So ROI can only be calculated, and ROI should be calculated for a period, let's say, now for example, the larger projects that we do. So for a particular component, the ROI could be, let's say, 3 to 4 years. For a particular component, the ROI could just be about 1 year. So the ROI calculations have to be calculated for the complete product life cycle. But currently, because of the fact, as what Amith was also talking about, कि 22 का विजन था हमारा कि इतने लाख स्क्वायर फुट कि 10 में से 4 बिल्डिंग्स है सिर्फ जो ग्रीन के लिए जा रही है. और 30 का विजन बहुत क्लियर है कि 10 में से 8 बिल्डिंग्स ग्रीन के लिए जाएंगी. तो जब 10 में से 8 बिल्डिंग्स ग्रीन के लिए जा रही है, तो इसका मतलब है जो बाकी का रॉ मटेरियल है बिल्डिंग में जो मिल रहा है, इसका मतलब जो एक बेसिक एलपीएम वाला नलका है वो तो बिकना ही बंद हो जाएगा. तो फिर रिवर्स कैलकुलेशंस होंगी, बिकॉज जितनी बड़ी मार्केट क्रिएट होगी उसके हिसाब से. आज लो वीओसी का जो पेंट है, लेट्स से लो वीओसी का पेंट की बाल्टी 100 रुपए लीटर आपकी ज्यादा है. लेट अस जस्ट गिविंग एन एग्जांपल. बट बाद में क्या होगा कि जो ऑर्डिनरी वीओसी वाला जो पेंट बिक रहा है वो बिकना ही बंद हो जाएगा, बिकॉज सभी लोग लो वीओसी लगा रहे हैं.
Correct. Scalability is always there.
Scalability is always there. So आज अगर हम बात करें 22 में things have drastically changed. पहले ग्रीन प्रो सर्टिफिकेशन जो थी वो सिर्फ 10 वेंडर्स के पास होगी. आज आईजीबीसी की जो ग्रीन प्रो की लिस्ट है वो इतनी बड़ी हो चुकी है कि हमें क्लाइंट के साथ जब हम बात करते हैं, हर कैटेगरी में you would have at least 10 to 12 players to choose a product from.
Yeah, that's there. So it's always dependent on the end user and finally how the market accepts the same.
Yes.
The costing is always dependent on that. One related question to our previous discussion came up. Is it feasible to do plantation of high leafy plants and fruit plants or simply grasses?
It is feasible to do all type of plantations. We don't recommend grass because grass सबसे ज्यादा पानी का use करती है. What we recommend is, drought tolerant species, and what we recommend highly is native species. So native species की कैलकुलेशन ये कहती है, फॉर एग्जांपल अब जिस रीजन से हम लोग हैं, हमारे रीजन में लेट्स से एक लिस्ट है जो 300-400 पेड़ की जो हमारे रीजन में बहुत कम पानी में भी उग जाते हैं. बट इफ आई एम इम्पोर्टिंग ऑल द ट्रीज फ्रॉम दुबई एंड आई डिसाइडेड कि नहीं, मुझे तो पर्टिकुलर वो एक्सोटिक स्पीशीज ही लगानी है जो वहां पर अवेलेबल है, और यहाँ पर हो सकता है उसकी जो वाटर रिक्वायरमेंट्स और जो उसकी नीड एंड केयर वाली जो रिक्वायरमेंट्स है वो कम्प्लीटली चैलेंजिंग हो, तो मैंने 100 पौधे लगाए, 100 में से 50 तो मर गए, तो उसका कोई फायदा नहीं है. सो द इंटेंट ऑलवेज शुड बी कि जो हमारे रीजन की नेटिव कैलकुलेशंस और जो नेटिव स्पीशीज है वो होनी चाहिए. बट लेट मी क्लैरिफाई, जब भी हम कोई भी प्रोजेक्ट की डिस्कशंस करते हैं, कभी ऐसा नहीं हो सकता कि एक्सोटिक स्पीशीज की टाइपोलॉजी ना लगे. So we always talk about that, let us limit that exotic species of typology of plants to let's say 5% to 10%, so that at the end of the day a clear list is being visible कि अच्छा इन plants की मुझे 10% की ही सिर्फ टेक केयर करनी है, बाकी 90 तो बहुत आराम से चल जाएंगे.
Correct. So just for my curiosity, even if you are doing some project without use of air conditioners at all, totally being with natural ventilation, and if that kind of project is taken up by you?
सर सी आज की डेट में हमारा जो क्लाइमेट कंडीशन है वो बहुत रेयर अलाउ करता है कि हम एयर कंडीशनर किसी भी टेम्परेचर कंडीशन पे मत यूज करें. वी ट्राई टू डू कपल ऑफ प्रोजेक्ट्स ऑन पैसिव कूलिंग टेक्नोलॉजीज, दैट वी शुड हैव पैसिव एयर कूलर्स and passive air cooling technologies by using ducts or something like that. But at the end of the day, there are very few takers for that. Yes, there are a couple of people who are really interested for that kind of a challenge, and people want to kind of invest on that. So for example, I would just give a very small example. We were doing a home, so there largely we started with this intent only कि जितनी ventilation हम ऊपर से गर्म हवा को निकाल सके, we must introduce those slit ventilators on top. बिकॉज जैसे ही आपने स्लिट वेंटिलेटर को यूज करा तो आपकी हॉट एयर जो थी वो हॉट एयर तो सारी की सारी एस्केप कर गई, एंड विद दैट ऑटोमेटिकली जो लिवेबल जोन्स थे, जो 6 फीट तक वाले जोन्स थे, दे बिकम मच कूलर.
So it was working as per the client's expectation?
Yes sir.
Okay.
Ultimately, as when it comes down to a challenge from aesthetics versus what is prevalent, then it becomes a challenge as an architect. Not as a concept, because then largely the question comes in the mind, okay, फलाने के घर में तो वेंटिलेटर नहीं है, अब आप मेरे घर में वेंटिलेटर दोगे. Aesthetics उसका मैच करने में थोड़ा सा as an architect you really need to push things forward. But otherwise yes, it is very much feasible.
Oh, that's great to know. One last query came on YouTube. That what kind of green materials people are including in ACC blocks, if some innovation is going over there also, and certain building blocks which might be used.
See, whatever material we are using right now, there largely we are using fly ash only as a sustainable product. So fly ash is one of the larger material that is being used in all of these typologies of blocks. And of course, now the newer blocks are using EPS insulation also. So with EPS insulation already inserted in the block, what happens that, you don't need to put another insulation to match the U value. That is really helping us.
Oh, that's good. So
that is really helping us. So now another example is what you were asking, as compared to passive systems being used for a regular residence. So we are even working in lime as well. So मुझे याद है राजस्थान से हमने इतने सारे ट्रक चूने के मंगवाए, because we were very sure that okay, अगर product use करना है तो चूना क्यों नहीं. We are doing lime plaster, and then we went on to that level where we are using Vedic plaster also. We are using Vedic plaster जिसको ना curing की जरूरत है, पतला प्लास्टर है, अंदर मैन्युफैक्चरिंग ऑफ दैट प्लास्टर बिकॉज सीमेंट और सैड का कंपोनेंट ही नहीं है, एंड इट इज यूजिंग कंपोनेंट्स लाइक काउ डंग, पीओपी एंड चूना, तो उससे ऑटोमेटिकली घर ठंडा रहता है.
Even we are doing some testings over there for Vedic plaster and lime based plasters in our labs also to get their VOC values, to get their flow test values. So more this gets published, this gets awareness into the people.
Yes.
Shailesh sir was commenting maybe something. I just interrupted.
I was saying in ACC block, so fly ash is a nuisance because wherever we have a thermal power plant or industry, which creates fly ash, we really don't know how to dispose it of. So fly ash we mix with the cement and using the process which adds the air to the system. So fly ash making ACC block is consuming the fly ash and helping the nature. So the fly ash as such is a material which we want to discard, it's no place. We can't dump it in a dumping yard. We cannot do anything. So I think students have not understood what fly ash is. It's a byproduct which we don't know what to do. So cement industry has come up with fly ash blocks which are very good for insulation, which are lightweight, so construction is easier. So wherever we use the column and beam construction methodology, there for covering walls, we use fly ash ACC block. So when we use it, we are increasing the green coefficient of the building. So it is using it so that our nature is safe.
Correct. Whole GPC is based on certain kind of using different kind of ashes, not just fly ash, bottom ash, coal ash, GGBS. So certain materials, as in our research level, we are also including, and we are seeing their results, how much sustainable they are, and how do we even do some certain workshops with PWD engineers and engineers around the Himachal to come into our labs and hands-on use these kind of materials and see their demonstration on concrete, what kind of effect it has on strength, on durability, on certain porosity qualities, how breathable they are. So these things we are also trying to tender with, and to tackle these materials in an efficient way to make concrete more sustainable and more green. So with these words, again, I'll thank all of our eminent speakers today, and we have gone much above stipulated time, and I'm able to see many people are still joined in. So I'm again very grateful to all of the participants, and specifically to our speakers today, Colonel Shailesh Pathak ji, Architect Shelja Gupta ji, Mr. Amith MC, and even Mr. Nilesh ji to coordinate everything on behalf of IGBC with us, our head of the department, Dr. Ashish, my IGBC students, in specific Mr. Ajay, the coordinator for the event, and all the community who are here and who have very patiently listened and asked very interesting questions to make this event a success. Once again, from bottom of my heart, I thank you all of you to attend these sessions. So I have just shared the feedback link. Kindly please fill in the feedbacks. Your e-certificates will be sent to you within 7 days of time. So thank you again, Shailesh ji. Thank you again, Shelja ma'am. Thank you again, Amith ji, for coming and enlightening us. Thank you.
Thank you, sir. Thank you, ji. Bye-bye. Bye. Have a great day. Bye.
Thank you.